All righty. So welcome back. And welcome to some of our new people. I hope you guys, whoever is a mom, enjoyed your Mother's Day just to yourselves. Sometimes we just need that. And then obviously we have some catching up to do, which is totally fine. So today we're going to go over math. That's going to be kind of our main subject that we're going to tackle. And math is a really big one because there's a lot of math that we've done obviously in school, depending on what are the classes and stuff that you guys have been in. So that's why it was a little bit robust for you, just to make sure that we covered everything. So I just want to first start with, does anyone have any questions or want to go over certain things in the math section?
Can we do drip rates?
Drip rates, yeah, absolutely. Anybody else?
I want to go over like the dilutions.
Okay, perfect. Anybody else?
The C1 V1 thing.
Yep. Okay, so dilutions for sure.
On the medical math part 4 with the heart rates.
Yeah. Oh yeah.
Yeah.
That one gets a lot of people, which I can understand. So anybody else?
The oxygen flow rate, like I know the formula is there and it looks so simple, but I feel like sometimes I'm overthinking when I try to do the calculation.
Okay. So you said flow rates?
Yes.
Okay. Anybody else? All right. So let's start with me opening a new sheet of paper to work on. All right, so if I go back to, let's see. I think it's the part 3. All right, so I know another one is the MEQs. We kind of went over. Okay. So let me just copy some of these problems and put them in here. Doesn't want to work nicely. Okay, whatever. Okay. I'm going to share my screen so you guys can see everything. All right, so I'm gonna first, oh, I forgot my chat. Dilutions, yep, and you missed large animal. Okay, so we'll talk about that in a little bit. All right, so for this one, the first one, what is the drip rate that you would use to administer 625 mils of LRS over 3 hours with a standard 15 drop per mil administration set? Okay, so we have 625 mLs, right? And it says that we need to give that over a 3-hour period of time. So we need to figure out first what our hourly rate is. Okay. So if you have a total of 625 mils and your doctor wants you to give that over 3 hours, what rate would you set that at? Right. So we're going to take that 625 mLs and we're going to divide that by 3 hours, right? To get our hourly rate. Okay.
208.3.
Okay, so 625 divided by 3, we have 208.3 mLs per hour. Okay. So now that we have that hourly rate, all right, now say you don't have a pump to put it on. All right. So we need to figure out our drops per second so that we can actually look at those drops and go, okay, how many drops am I giving over how many seconds? And that should equal that 208.3 mils per hour. All right. So we're going to take that 208.3 mLs and we're going to change our hours here to seconds. Okay, that's the goal. So does anyone know first how many seconds are in an hour?
3,600.
600. Yeah.
3,600. Good. So 3,600 seconds. Okay. So that means that we have 60 seconds, or I'm sorry, 60 minutes in an hour, right? And
Yeah.
then 60 seconds in each minute. So then we multiply those together, and that's how we got that 3,600. Okay. So if you guys just remember the 3,600 seconds, then you don't have to do all that additional like math, that you might have seen in school. You could just do it this way. So then we're gonna have to put in our drip set. Okay, so in this problem, it's nice because it was told to you what the drip set we're using is. Okay, versus maybe if you had a patient's weight and then they told you to figure out that drip set, like in practice, you'll have to figure out which drip set you're going to want to use, right? So our macro drip set is 15, think of it as 15 big drops, macro big drops per mil. And then the micro drip set is 60 small drops per mil. Okay, so if we have a smaller patient, like under 7 kgs, we're going to use a micro drip set because we can control that a little bit more. But if we have a larger patient, something over 7 kilograms, or for bolusing or something to that nature, then we're going to use the macro drip set. That way it can get to the patient faster too, right? So in here, we're technically using this macro drip set. So 15 drops per ml. Right?
Yes.
So that is all you need to set up our problem right here. Okay. So as you look at it, we cancel out our mils. You set it up correctly because you cancel out your mils. And then you are left with drops per second. And that's what we want. Okay. So 208.3 times that 15 divided by 3,600. And you can do the math either way. You could do 208.3 divided by 3,600 times 15, either way. So that gives you 0.868 drops per second. Okay. So for the VTNE, this is your VTNE answer. Okay, you just have to go to there, which is pretty easy and nice, right? But in real practice, real life, we have to be able to give a whole drop per a whole second number. Okay, there's no decimal places. You can't do a decimal drop. So in this case, you are going to have to add seconds to try to get this number to be a whole number. So what would we multiply this by for seconds? What would we multiply it by to try to get a whole number?
Mm. Can you do 2 seconds?
Can't.
So if you multiply that 0.868 times 2, do you get a whole number?
No.
Okay.
1.7.
Okay. So let's try a different number. And like I said, you can play with it. And it can be as close to the whole number as possible because it may not always work out perfect, right?
Yeah. So if you times it by 7 seconds, you get 6.076.
Yes.
Very good. Very good. So we multiply that by the 7 seconds and we get 6.9, blah, 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 right? So
Yes.
that's how we're going to do it. Okay. So it's close enough. We need to get it as close as we possibly can so that we can stay at our hourly rate. So because it ended up being 6.9, blah, 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 whatever, that means that we have what, 7 drops. Let me just, oops, I screwed this up. 0.868 times by 7 is 6. Okay, 6 drops
6 drops. Yep.
per 7 seconds.
But we
Alright.
won't need to
Yep.
do that on the VTNE.
For the VTNE, you won't have to do that. Okay, you just get to go to this part, which is nice because, there's so many multiple answers that you could do. Like someone might say it's 12 drops per 14 seconds, right? Like they just double it.
Right.
So that's why they have you guys just go to here, which is so much nicer for you guys to not have to do this step. However, this step is important for you to know because if you are in a practice where maybe your pump stopped working or you're doing this for surgery patients or whatever, or God forbid we have, a power outage and all the pumps don't work anymore, something to that nature, then you have to do it this way. Okay. So that's why I like to show you this way and not just leave you with just that one step with the VTNE answer. All right. So let's try. I'm going to have you guys try this next one. Okay. So we have a drip rate that we're going to use 475 mLs of plasma light over 8 hours using a micro drip set. Okay, so it tells you which one to use, but it doesn't tell you what that is. So I'm going to give you guys a couple minutes. I want you to work on that and then we'll work on it together. Okay. All right. So it's okay if you still aren't done, you can keep working, but for what are we gonna do first?
Find out how many mils per an hour you're giving the 475.
Okay, good. So 475, oops, can't write. 475 mLs. Okay. And then how many hours?
8.
8 hours, good. And so what is our mils per hour?
59.3 0.75 mils an hour.
Wonderful. Good. And so what is our next step? So that was the first step one. What's our next step that we're going to do?
To
Find out
convert
how
that to seconds.
How many seconds? Good. So we take our 59.375 mLs. Okay. And then how many seconds?
3,600.
Good.
3,600
3,600 seconds. Very good. All right. And then the other thing we have to put in here is our what?
drops.
Drops.
Drops. Okay. So what are our drops?
60.
60. Good. 60 drops per mil because we're using a micro drip set. Okay. And so what did you guys get as your total?
I got 0.0164.
I got 0.989.
Good. 989 drops per
Oh.
second. So yeah, try to do that math one more time and then you. All right. So remember VTNE answer here. Okay. Now, if we were to go the next step, I made it easy for you on this one, right? This is really, really close to that one drop, right? So we're probably not going to get any closer by multiplying another whole number to it, right? So we can actually just leave that as 1 drop per second, right?
I
Yes.
added in another step. I don't know what I was doing.
Okay.
Just ignore me.
So yeah, so we have 1 drop per second because we're so close to 1 right here, right? No matter what we multiply by, this is the closest that we're gonna get. Okay. All right. Any questions on those? Easy? Easier?
Yes.
Good.
Yes.
All right. Perfect. Let me pull up some more. Oh yeah, right. This is a good one. They all probably love me for. Oops. Okay. Okay. So, oh, it didn't copy the full thing. Darn. Anyone do the problem that asks for dehydration, ongoing losses, and maintenance? It's like a kind of a
Yeah.
larger problem. Okay. We're gonna do
Try.
that. It's all good. So,
What number was that?
this one, it's on your, I think, math 3 week and problems 12 through 16. Okay, so
I printed them off.
so we have a 7.5 pound Pomeranian presented for anorexia and vomiting. All right, he vomited 2 times, about 3 tablespoons each time, and had 3 ounces of diarrhea 1 time. All right. Your veterinarian orders diagnostic workup, including blood work, urinalysis, abdominal radiographs, and then she also orders IV plasma light and asks you to calculate the infusion rates and drip rates. Okay, so that's a lot of information to unpack. So here's where we need to identify what's the important information in here. Like, the attending veterinarian orders diagnostic workup and blood work, urinalysis, abdominal radiographs, that whole entire sentence we don't need, right? Like, that's not the purpose of this problem. It's good to know because we're going to follow up with that later, right? But they also order IV plasma and ask you to calculate the infusion rate. All right. So all the other information we need, the last sentence is just like what they're going to be asking us to figure out, right? So calculate the fluid deficit for this patient. So deficit is our dehydration. Okay. So what is our dehydration formula?
It's the percent.
Weight times amount dehydrated.
Let's see. Okay, so weight being in, we'll say kilograms, times what we're dehydrated in, right? So
Mhm.
the percent as a decimal,
Times
good, times what?
1,000.
1,000, good, gets us into mLs. So just remember that the times 1,000 is getting us from out of liters to milliliters. Okay. I think of it as we used to care for a lot of large animal. I mean, we still care for a large animal. But that was like in veterinary medicine, our main patients was large animal, right? So for large animal, you're going to be giving them liters at a time and not necessarily milliliters if they're dehydrated. So, but for small animal, we're going to be giving milliliters. So we need to convert that. So we start with our kilograms and then we take our percentage and put it in a decimal and then multiply that by 1,000 to get how many mLs we're dehydrated with. Okay. So in this case, we have a 7.5 pound Pomeranian. So how do we get that into kilograms?
Divide by 2.2.
Good, divide by 2.2, right? So we have kilograms is 3.4 kilograms. Right? And then percent dehydrated is they're dehydrated at 8%. So we're going to change that into a decimal. Okay. And then we're going to multiply that by 1,000. So 3.4 times 0.08 times 1,000. So they're dehydrated 272 mLs. Okay. So that is one of the answers we have to keep track of. All right. Now we need to calculate the maintenance fluid amount needed for this patient for the next 18 hours. Okay, because we are going to be rehydrating this patient, it looks like, over the next 18 hours. All right, so what is our fluid maintenance rate?
60 mils
60 mils per what?
hour. 60 mils per kg
per
per
day.
hour.
Good.
Or
60.
yeah, per kg per day.
Good. I'm like, you're gonna make that patient float away.
I know, I was
Uh,
trying.
60 mils per kg per day. Okay. All right. So the interesting thing is that if you want, all right, in the AHA fluid guidelines, it has that the dog maintenance rate is 2 to 6 mils per kg per hour. Okay. And cats are 2 to 3 mils per kg per hour. All right. So, as we've learned many, many years previously, it's been 60 mils per kg per day, blah, blah, blah. Right. However, the maintenance rate for younger pets like pediatric pets, those types of things are actually higher. So that's why it's that huge range, 2 to 6. Okay. Because like the maintenance rate for puppies is like 180 mils per kg per day or something crazy. It's big. Okay. Which we don't learn that in school. So my point is that if we took that 60 mils per kg per day and made it into an hourly formula, this can make your lives a little bit easier too. Okay. So if you take, there's 24 hours. If you take 60, divide that by 24, right? That means that we can convert this to 2.5 mils per kg per hour. Okay. Because I'm saying this because we don't need the entire day. We need 18 hours. Okay. So if we input that information, the kgs and the hours that we need, we can get the total amount of fluids that we're actually going to need. Okay. So we'll take 2.5 mLs times that by the kgs, which is 3.4, and then times 18 hours. Okay. You can also go backwards and do like the 60 mils per kg per day, like for the 24 hours worth for the day, and then divide that by 24 and then multiply it back to 18. That's fine too. However, this is just nice to keep in your back pocket of knowing, okay, 60 mils per kg per day is actually equals 2.5 mils per kg per hour. Okay. Now, what do we get for our total amount? 2.5 times 3.4 times 18 hours.
153.
153. Good. So 153 mLs per 18 hours. Okay. So that's our second answer that we're going to need. All right. Let me just check. All right. So how we got 2.5 was by taking that 60 mils. And then remember that our day's worth is 24 hours. So 60 divided by 24. We're leaving that kilograms because we're going to still need it. And then it brings it to that hourly rate. So that's where it got that 2.5 mils per kg per hour. Okay. All right. So ongoing losses. All right. So what are our ongoing losses? We first need to know what ongoing losses is. So our maintenance rate makes up for how much fluid we need in a day to survive like our normal regular day. Okay. However, it doesn't take into account if we've had ongoing losses of some sort, so additional losses that are not expected, meaning if our patient is vomiting, if they have diarrhea, if they, in our case, even I guess pets, but if they're sweating more than they should or normally do, if they're urinating more than they normally do, right? So excessive urination, those types of things. So that's our ongoing losses. Okay. We can even say for dogs or cats, I guess, if there's excessive panting, because they're going to be losing some fluid there. But typically when we see it, we see that it's like vomiting and diarrhea is the big culprit of it, especially when we have sick pets, right? Now, when you have pet parents come in to, to be seen, they aren't going to tell you, yeah, they vomited about this many mils, right? We just don't, in normalcy, we don't talk like that, right? So they're going to tell you something that makes sense based on a lot of times like what they cook or whatever. Like they quantify it by cups, teaspoons, tablespoons, whatever, right? So we have to be able to convert that to our mils. All right, so that's where conversions come in. All right, so we're going to pay attention to they vomited 2 times 3 tablespoons each time. Okay, and then 3 ounces of diarrhea 1 time. All right, so let's take this on slow with vomiting. Okay, let's just do vomiting. So they vomited 2 times, right? 2 times. And then 3 tablespoons. So 3 times, how many mils are in 1 tablespoon?
15.
15. Good. So 15 mLs per tablespoon. Okay. So now we just put all these together. So 3 times 15 is what? 45. 45 mLs. Good. And then we're going to multiply that by 2. So we get 90 mLs of vomit, right? All right. Okay. So now the diarrhea. Okay. So we have 1 bout of diarrhea. Okay. And it was 3 ounces. So 3 times, how many mils are in 1 ounce?
30.
30. Good. Okay. So 3 times 30 is
90.
90. And then they only had 1 bout of it. So that's 1 sip. So it's 90 mLs. Okay. So now we have to add these guys together. All right. And that's going to be how much ongoing losses that they've had. Okay. So that's 180 mLs total. Okay. So now we need to calculate our infusion rate for the next 18 hours. Okay. So we add all of these together because these are all very important to fix for this patient. So 272 mLs plus 153 mLs plus 180 mLs. All right. And that's going to be how many mils we need in 18 hours. Okay. So 272 plus 153 plus 180. 605. Okay. For 18 hours. All right. So what is our hourly rate then?
$33.6.
Good. 33.6 mLs per hour. Okay. So we just take that 605 divided by 18 to get that 33.6. All right. So our next part here is what is the administration, or I'm sorry, what is our drops per second using the appropriate administration set? Okay. So just like we did in the last stuff in the last section we worked on, we're going to take that 33.6 mLs. And how many seconds are in an hour?
3,600.
3,600 seconds. Okay. And then what is the administration or drip set that we're going to use?
7.5. A macro.
Okay, remember it is anything less than 7 kgs gets a micro, greater than
Oh, no,
7.
a micro. I'm sorry.
Yep, you're good.
Yes.
So 60 drops per ml. Okay. Okay, good. So now we can do our math. So 33.6 times 60 divided by 3,600. Get 0.56 drops per second. Yeah.
Mhm.
Okay. So what if we want to figure out the actual whole numbers? Any ideas?
Well, if you times it by 2 seconds, you get 1.12. Can you round down?
Potentially can.
Mm. You can do it by 5 seconds and get 2.8 and round up to 3.
Okay.
If you do 25, you get 14.
0.56 times 25. Oh, you do get 14. So who wants to sit there for 25 seconds?
Nobody.
But you're right, that we could.
At 12.
So let's see. Times by 25 seconds, we get 14 drops per 25 seconds. So I guess that's the most ideal, right? That's going to be our most ideal. When I'm looking at it, 0.56, I will say that we're probably, you're probably right about you said 2 seconds, right? 0.56 times 2 is
Yeah.
that 1.1. So if you didn't want to wait that 25 seconds, which no one really does, that's going to be our closest. Okay. So very good. Times 2 seconds. Okay, 0.56 drops per second. Times 2, we technically get 1.1, right? But we're gonna move that down to 1 drop per 2 seconds. Okay, which we know that 1 drop per 2 seconds as a fraction, 1/2 is 0.5. So that's where it's a little bit off, and that's okay. It's not changing our fluid rate that much. But if we have the time and want to sit there for 25 seconds, you can, okay? To be exact. All right.
We
So- Go ahead.
all have those people that are willing to sit there for 25
Oh, I'm
seconds on our
sure.
team.
I'm sure. You're right. You're like, how much can I get done in 25 seconds that I don't have to be here? So, and these are why fluid pumps are so much nicer, because there can be such a variation of how we do our drip rates. So fluid pumps make it very exact for us. All right. So these came along for the ride when I copied them and pasted them in here. Okay. So I'm going to do this. All right. I know some of you guys might have tackled these or had questions on this as well, but hopefully I was able to answer some of this other day for you guys. So how many of you guys went
Can you go over it real quick?
Yep, of course. How many of you guys went over acid base stuff in school?
No.
No?
If I did, I don't remember.
Yeah, I
Yeah.
don't remember it either.
Yeah. And it's really interesting because like these are things that we all need to know anyway. And I truly think 2 things. We need to update our AVMA skills for you guys in schools to make it something that we have just a basic understanding of, which would be great. And I'll be honest, as a teacher, many of the teachers don't feel comfortable with the knowledge of acid-base stuff. It's just sad. We need to, because we do blood work all the time. And this doesn't explain, or this explains, I should say, why maybe some of our patients have certain other symptoms. And then that way we're not leading ourselves down the wrong path because we don't understand acid base. Okay. So my biggest thing is when I was in practice, and I think I was in school at the time, was we had a DKA patient come in. So probably most of you guys, if you've been in practice, have seen a DKA patient, right?
Mhm.
Yeah.
Yeah.
So as we
Mhm.
know, DKA, the A part is acidosis, right? And they're metabolically acidosis, have metabolic acidosis because, as we know, diabetes is a metabolic response, right? So part of that is that the body tries to compensate for its blood being completely off whack. So you will see with patients that have metabolic acidosis that they start breathing heavier or maybe even pant. And it then tries to even out the pH on its own. Okay. Which again, I did not understand this because I wasn't taught yet, that type of thing. And so when it was a pug, I remember when he came in, I was like, oh my gosh, this animal has to be oxygen dependent because it's breathing so fast, it's breathing so heavy. And I kept checking its SpO2 and whatever, and the SpO2 was normal. And I just threw him in oxygen because I was like, I don't know, I feel more comfortable that way. Plus, it's a pug, whatever. And my doctor kept going, no, it's normal for this dog. Don't worry about it. Like, he's acidotic. And I was like, I don't know what what you mean, that type of thing. But then once I learned about acid base, I went, oh my gosh, I was being a total idiot, even though I wasn't. But like, the body is compensating for itself, which I think is super, super cool that our bodies actually try to fix themselves. Okay. And so you will see that respiratory rate or the CO2 level goes up on those metabolic acidosis animals and to fix the rest of the body. So that's pretty cool. So first we need to know what our normal ranges are when we're doing this. All right. So pH, what's the normal range of pH? Anyone know? For blood.
7.3.
Good. 7.35 to 7.45. Very good. Okay. So anything less than that 7.35 means that our patient is acidotic. Anything greater than the 7.45 means that our patient is alkalotic. Okay. So now, what are the normal ranges for CO2?
$35 to $45.
35 to 45.
Good. 35 to 45, right? So a lot of you guys know from anesthesia stuff, 35 to 45. Now, a good way to remember is 7.35 to 7.45, and it's 35 to 45. Look how easy that is. Okay.
Oh, yeah.
So it makes it super easy, except for our HCO3, which is known as our bicarb. Okay, so if any of you guys have heard of bicarb, that is our bicarb. Okay. So what's the normal range of bicarb? It's not 35 to 45, unfortunately.
22 to 26.
Good. 22 to 26 millimeters of mercury. Okay. So that's the only one we really have to memorize. Okay. So now thinking about it, CO2 comes from where?
Lungs.
Lungs. Good. So our lungs
Lungs.
are respiratory, right? So
Mhm.
if something's wrong with our CO2, then we have a respiratory issue. Okay, that leaves our bicarb, right? Bicarb actually comes from our kidneys. So that is our metabolic. All right, so if something's off with the HCO3 or the bicarb, then it's a metabolic issue. All right. So the first thing that we're gonna do is we're gonna evaluate the pH and say, okay, is it normal? Is it acidotic? Is it alkalotic? And then we're gonna look at both the CO2 and the HCO3 and determine which one of those are off. And the one that's off is the one we say, okay, it's respiratory or it's metabolic. All right. So in the first one here, so 17.
No.
Okay. Are we normal, acidotic, or alkalotic?
Acidotic.
Acidotic.
Acidotic, good. Acidosis. All right. Then we look at our CO2 and our HCO3. So CO2 is 49, HCO3 is 21. Of course, I give you a hard one right away.
So it's respiratory acidosis?
Good. So respiratory acidosis, because, okay, again, both of these are off. All right, because this is 21, just barely off. Okay. This CO2 is more off. So that's the culprit. That's the issue right there. Okay. This one is how I say the body's compensating. Okay. It's trying to compensate for the respiratory acidosis. Okay. So again, why I gave you the hard one right away, I'm not really quite sure, but I did. So, but even if it was 22, okay, so it's in normal range, we're still respiratory acidosis. All right. All right, that one was the hardest one, I'm sure. Okay, so 18. pH. Acidosis or alkalosis?
Alkalosis.
Alkalosis, very good. And then HCO3 and CO2, which one is not in the normal range?
CO3.
HCO3, good. So that makes it a
Metabolic.
very good. See how easy that is?
So
And
would
who-
that be called metabolic alkalosis?
Correct.
Okay.
Yep. Yeah. See, now you guys have all that smart lingo. You can be like, oh yeah, this patient's metabolically has metabolic alkalosis. And then people are like, what? How did you know that? I'd be like, oh, it's hard stuff. I can't even tell you. All right. So next one, 7.29. Are we acidosis, normal, alkalosis?
Acidotic.
Acidotic, good. So acidosis. Okay. And then we're gonna look at our bicarb and our CO2. Which one is not normal?
Bicarb.
The
Oh,
bicarb,
this, yeah.
metabolic acidosis, right?
Yes.
So here's like our DKA patient right there, metabolic acidosis. Okay. All right, 20. pH, where are we at?
Alkalotic.
Alkalosis, good. And then bicarb and CO2, which one is off?
Respiratory.
Respiratory, very good. Very good. Easy stuff?
Yes.
Yay! I'm glad. Awesome. All right. 1, 2, math knowledge. Okay. All of these problems, remember, are going to be in Canvas. So in the math section. Plus there's a ton more. Okay. Let me take a peek here at oh, here. We're gonna take on a couple of these. Anyone do the insulin syringe one?
I think I did. I
Good.
gotta find it though.
Good. Okay. So we are going to, I'm gonna throw these in here. All right.
What number? Oh,
I
on
think it
number
was
10?
10, yeah. Yeah, on the first or the
Yeah.
okay. So
Yeah. Can I
you're
tell you what I got?
sure.
0.4 units
You're
or 4 units?
4 units, and then let's talk about how we get there, right?
Mhm.
All right. So ace promazine, okay, we have a dose of 0.025 mg per kg IM. All right, for our hemilaminectomy surgery, our patient is 26.5 pounds. If we want to give an accurate amount, we're going to use a U100 syringe, all right, insulin syringe. Our concentration of ace-promazine is 10 mg per mil. So how much will we give? And then it also asks what location are we going to give it in if we're giving an IM injection? Okay, so there's 2 parts.
Need to have pH.
Okay,
and then
so first let's figure out our dose. All right, so we have 0.025 milligrams. And then it's per kg. So how many kgs is our patient? £26.5.
6.74.
26.5 divided by 2.2. I have
Divided by 2. Oh, 12.04. I don't know what I put in my calculator.
okay, 12.04 kilograms. Okay. All right. 12.04 times that 0.025. And our milligrams we have here is 0.301 milligrams. Is that correct?
Yes.
Okay. And now we need to figure out the mils, right? So if we have 0.301 milligrams, and to figure out the mils that we need, we then divide that, right, by the 10 mgs per ml. Okay. So if we divide that by 10, we get,
3 units.
so 3 mLs, right? Now, as you guys can see, if we gave that in a TB syringe, there's that huge hub that's in there. So that 0.03, we don't have an accurate amount that we're giving because that hub is there. So that's why it's nice to be able to use the insulin syringes because there's no hub that's there. But we also need to know how much to give with that insulin syringe. So U100 means that there is 100 units that make up a mil. So we can measure it that way. Okay. So that then means that there is 0.01 mLs equals 1 unit. Okay. Because if we have 100 of the units, right, and we multiply it times the 0.01, that will get us 1 ml. All right. So when I look at this and I say, how many units am I going to give? How many units is it?
3.
3. Very good. So 3 units. Does that make sense to everybody?
Can you share your screen?
Oh my gosh, I'm so sorry. I thought it was shared. Special. All right.
That's still good. calculating the deficit.
Sorry, what?
That's still calculating the fluid deficit.
That's at the bottom, at the
Yeah.
top. So
Yeah, so here's the bottom here, but I'm at the top, right there.
Okay.
Do you see right here? Okay, any
Yeah, no, I do.
questions on that?
I'm old, y'all.
No.
Will you leave that up for 1 second?
Yeah, of course. And then, if we have a 50% dextrose, so this is what I know a couple people wanted to go over. Our most infamous, RER, yeah, of course. Infamous, C1V1 stuff, right?
mm,
Yeah. C1 times V1 equals C2 times V2. Okay. So anytime you see that we are making a new concentration from an already concentration, like an already concentrated thing, that's our C1V1 times C2V2. Okay. So if we have 50% dextrose and we need to make a 1.25% solution and we have 375 mLs left in our bag, how much 50% dextrose will we need to add? All right. So this is where our minds go, we can't do it, but we can. Okay. So what I do is I make my little blanks in here so I can fill things in. Okay. Equals C2 times V2. Okay. So my blanks represent that C1 times V1 equals C2 times V2. Okay. Remember that C1 and V1 are the OGs. Okay. So the original concentration, the original packaged goods that we're going to use. Okay. And then the C2 times V2 is the new solution we're making. All right. So the original packaged dextrose that we are using is what? What concentration?
50.
The 50. Very good. So 50%. You do not have to change that 50% from anything else. It just stays that way. Okay. Now, do we know how much dextrose we are going to need from that OG bottle?
No.
No, not yet, right? That's what we're trying to find out. So we put an X there. All right. And then our new concentration. What's our new concentration that we're making?
1.25%.
Good, 1.25%. And then do we know how many mils is going to be in that?
375s left in the bag, so it'll go in that.
Good, 375. Very good. So we have it all filled out. How perfect. Okay, now we just have to do the math for it. So we're going to drop all of our units because we know that the X is going to end up as an ml because that's our volume. Okay. So we're going to take 50x, right? Equals that 1.25 times 375. So what's 1.25 times 375?
468.75.
468.75. Now remember, we need to isolate that X. Okay. So we're going to divide both sides by 50. And what do we get?
9.375.
Good. 9.375 mLs. Okay. So that is the answer. Super hard?
Mm.
Or easier?
It's not. I always convert like whatever I need, what I'm trying to get, I convert it to mix per meal
Okay.
and then multiply it by how much fluid I have and then divide by like the original concentration.
Okay. So you would have taken that 50%, and change that to mgs per mil being 500 mgs per mil. And then same thing with the 1.25, change that to 12.5 mgs per mil.
12.5.
Yeah. Okay. So that's completely fine if you want to do that. You just have to make sure that you are matching those units on both sides. So you can't have like a one that's mixed per mil and then the other one that's a percent. You're just doing a lot of extra work for yourself. So it's up to you. If you want to do it that way, you can. It's just obviously a couple extra steps that you're taking.
It's gonna be harder, right?
Yeah. So, but it's still fine at the end of the day. Like if they would have given you this 500 mgs per mil, if they said, oh, you know, we have dextrose that's 500 mgs per mil and you need to make a 1.25% solution, then you would have to make a choice of, do I want to make them match by doing both as a percent, or do I want to make them both mix per mil and do it that way? If that makes sense to you. Which I feel like most people are going to go towards the route of mix per mil there because they're used to converting percentages to mix per mil and not necessarily mix per mil going backwards to that percent. But you can do either or. Okay.
Okay.
Yeah, but that's fine. Can we also do CRI? Yes. Yes. All right. Any questions on that?
So how do you know if you would round up to 9.4?
Good question. So, you would normally round up to 9.4 anyway, because you want to round to what you can draw up. We can't technically draw up, our 9.375, right, in a syringe. You just can't do that. So yeah, you would round up to that. The nice thing for the VTNE is it's all ABCD, so you're just gonna pick the closest, you know, number that's there. They're not gonna give you one answer that's 9.375 and then 9.4, so they won't do that to you.
Okay, good.
That would just be mean. Okay, so let's do one more of these so you guys have it down pat, right? So we're instructed to make an 18% chlorhexidine solution using 60 mils of 0.9% NaCl. Okay, our stock solution of chlorhexidine is 45%. So how many mils will we need from our stock solution to make that 18%? Okay, so again, we're doing C1 times V1 equals C2 times V2. Okay. I have seen so many people get tripped up at one spot of this. Okay, because they see a percent and they're like, oh my gosh, I have to put it into this formula. The 0.9% NaCl, remember, is our fluid that we're using. Just like if I said LRS, right? It's the type of fluid we're using. So we actually do not need to do anything with that percent. Okay. All right. So what is our original stock concentration?
45.
Good, 45%. Okay. How about the original mLs? Do we know that from the stock?
No.
No, good. So again, we're setting this up very similar to the other one. And then what's our new concentration going to be?
18.
18%. Okay. And then how many mils are in that new one?
60.
60. Good. 60 mLs. Okay. So we can drop all units there because we know that we're working with mLs. And we are going to do 45x equals that 18. Sorry, my handwriting's terrible. 18 times 60. So that's 1080. Okay. We divide both sides by 45. And X equals 24 mLs.
Mhm.
Yeah, okay.
Yes.
Now let's do something with chlorhexidine that's more realistic. If anyone's ever done, has anyone ever cleaned any wounds with chlorhexidine or flushed wounds with chlorhexidine?
Yes.
Yes,
Yeah.
okay. So how do you make that solution? How do you guys make it in practice?
You add water to it?
We
Okay,
just
add water. How much chlorhexidine do you put in there?
honestly we just do a splash.
A splash, okay.
Which
I
I know is
believe
wrong. I know it's
5
wrong.
Yeah,
mils.
right. No, absolutely, right? It's so I like doing this one because we all do it so weird. So,
Is it
Steve was
supposed to be a
laughing
1 to
when I
10
said that.
ratio?
well, let's figure out what that ratio is. What is our chlorhexidine? Your like
5
1 to 10 is probably the closest that I've actually heard someone say. So that's pretty good. So when we get chlorhexidine, it's typically a 4% solution. Okay.
Mhm.
So Clorox. And if we are trying to make something to flush wounds, what is that supposed to be?
Healing.
2%.
Sorry, what?
I think 2%, but I'm having a
2%.
moment.
Okay. So 2% is actually like what we scrub for like IV catheters or like surgical stuff. So you're not, yeah, like 2% in your brain. It's not bad because we do use that too.
Okay.
So, but if you're flushing like an actual wound, that's gonna do some damage to your tissue. So we can't have it that high.
Okay. That makes sense.
Yeah.
Mm,
Would it be a 1%?
No, not 1%.
0.5%.
Yeah. Yeah.
Okay. I was like, keep going down.
Um, sorry. Let me just. Okay. So all right. So 0.5% chlorhexidine is what we really want. Chlorhex. Okay. So how many mils do you guys typically draw up for wound flushing? I mean,
We
it
do
does
about 10 mils.
about 10 mils a total to flush a wound,
Depending on the wound.
depending on the wound. Okay, yeah. Actually, anyone make up a full bag of like stuff to flush? Whatever. I've seen that done where people will like just put it in a full bag.
I've seen it too, but we don't typically do it. We use the 1 liter irrigation bottles.
Okay. And then how much of that do you use for flushing wounds?
It just depends,
Okay.
honestly.
Yeah. Like it might have a big wound or
Yeah.
So
Yeah. Sorry.
let's do 500 mLs. Like let's break that in half at least. Okay. So say this is like a patient that we have multiple wounds that we're flushing. Okay. So we're gonna make a 500 ml bag. All right. So if we set this up, okay, our 4% goes there, right? We don't know how much yet, what we're doing. And then we want 0.5 here percent. And then we're making a 500 ml. Okay. So if we put that together, 4x equals 0.5 times 500. What is that? 0.5 times 500 is 250. Okay. So we isolate this. So divide by 4 on both sides. And we get how much?
62.5.
Very good. 62.5 mLs. Okay. So think of that though as, oh, you know, we're making a half a liter. If we were to make even 50 mLs, so say you made 50 mLs, we just move our decimal over here, you're going to need 6.25 mLs of that. Okay. So do you
So that's
guys,
how much chlorhexidine I would have to pull up to add to a 500 ml bag.
correct. Yep.
Okay.
If you just did 50 mLs, you are pulling up 6.25 mLs. Yeah. So you guys do that pretty regularly? Of like how much you're flushing? Sometimes you'll even have it where doctors want it even less than that 0.5, which is fine. Okay, so that's where it was, someone said the 1 to 10 is pretty rough estimate, right? It's a little bit less than, you know, like we're talking 1 to 10 here being you do 5 mLs per your 50 mLs, right? That's a 1 to 10. So that's as close as I've seen someone actually say we've done it that way, a 1 to 10 or whatever, versus a lot of us were like, oh, just make it very, very pale blue or whatever, right? So good. All right. So I just wanted to give you guys yes, C1V1 does work if you need to find the concentration. Okay, so this is why I like to set it up this way versus some places will have you memorize just how to figure out this volume. Okay, so they'll be like, oh, it's the concentration times that new volume over the original concentration. They're right on that, but what if you need to find out something else? So that's why I like to set it up like this first so that you guys can figure it all out on your own. So say we had, I've got to take this for instance. I am going to say that somebody made a bag of, actually we'll change all this. Somebody made chlorhexidine for you. They put it in a 100 ml bag. And then they said that the, we'll say this is 2%. Okay, we'll just change it up. So they said that it was 2% on the label. They put 100 mils in and they told you that they put 40 mLs into that solution to make it 2%. Okay. So then you're like, well, what's the original concentration? Right? That's the unknown right here. Okay. So whatever the unknown is, make sure that you know that that's the units. So the unknown here is a percent. All right. So then we're going to do the exact same thing of our math. So we do that 2 times 100 is 200. Okay. And it's 40x. All right. So divide both sides by 40. And what do you got? X equals
5%.
5. $200 divided by 40. 5.
Yeah. Yep.
Okay. So we started out at 5%. Okay.
Okay.
Make better sense. So it's just
Yeah.
based on whatever that problem gives you and how you formulate it. As long as you can put them in the right spot. So knowing that this is the original on this side, that's how I set it up, right? The original. So I don't get confused. Original and then the new concentration that we're using. Okay. So even if they don't give you this one, then you can figure it out based on knowing, okay, well, we started at a 5%. Maybe that person's like, oh my gosh, I put 40 mLs of the 5% in and the total is 100. What's my new percent? Then you can just do the math that way, right? So 5 times 40 divided by 100 because this is size. Okay.
So the percents are always going to go on those first lines. That's always your C1
Yep.
and your C2. Okay.
Yep. Whatever your concentration is. So it could be a percent. It could be milligrams per mil because that's a concentration too, right? So whatever that concentration is, your volume is going to be however much it is. So is it in liters? Is it milliliters? Is it tablespoons? Is it ounces? Most of the time it's going to be mils. We'll just say that, but you never know. If you're working in large animal, it might be liters. So, okay. That's like the hardest one for me to have remembered was C1 V1. And then once it finally clicks, it clicks. And then you're like, okay, I can do anything now.
I think for me, it's because how they explained to set it up in school. And I was like, there has to be an easier way. Just like with drug calculations, I don't draw the whole table to pull up, how much cefazolin am I going to use?
Yeah.
I need an easier way to do it.
Yeah. No, absolutely. I'm like, what table? What are you talking about? Yeah. Okay, so let's go over CRIs because I know that people have an hard time with CRIs. All right. So if we're gonna put together a CRI for a patient, there are many different ways that we can do it. Okay. A lot of times we put them in bags of fluids. And sometimes we just put them by themselves or we create a bag or whatever. So I'm going to show you guys at least this problem to start. And then we can go from there. So, we have a patient that's 84 pounds. Their fluid rate is 200 mils per hour, and they have 800 mils left in their bag. All right. So how many mils will you add of each drug to that bag? All right. So in order to solve any of these, we have to find out the information on here. So we need to find out the kilograms of that pet and how many hours that we're going to need, or in this case, how many minutes that we're going to need. All right. So let's do the easy one first, the kilograms. So how many kilograms is this pet?
38.18.
Okay. 38.18 kilograms. Okay. Now we have to figure out time. So how long are we going to make these medications last? All right. So how do we do that?
Well, if you only have 800 mils in your bag and you're running at 200 an hour, don't you divide 800 by 200 to figure
Very
out how
good.
long the bag will last?
Very good. So 800 divided by 200 is 4 hours, right? So that makes it easy. And then if we need minutes here, which we do for this one, for ketamine, we just take that 4 hours and multiply it by 60 minutes because that gives us how many minutes are in 4 hours, right?
Yes.
So how much is that?
240.
240 minutes. Very good. So we're just going to keep that in our wing until we need it. So for morphine, okay, these are the concentrations of the drugs, by the way. So we're gonna set it up with 0. Try to write it nicer, so 0.5 milligrams times or kilograms, 38.18 kilograms times how many hours, right? 4. So this is going to tell us how many milligrams we need for the rest of that bag, okay? So 0.5 times 38.18 times 4, okay? So that is 76.36 milligrams, okay? So this is like how you would calculate, even like we talked about cefazolin. Cefazolin, we're all giving it at once as a bolus, right? So that's why you only have milligrams per kilogram. But when we're not doing it as a bolus and we're doing it over a period of time, then we have to add that time in there, okay? So you still have that milligrams times the kilograms and then add in or multiply in that time, and that's what gives you the total milligrams, okay? So with the total milligrams that you need, so we need 76.36 milligrams. Now we need to figure out how many mils. So what are our mgs per mil here is 15 mgs per mil. So we're going to divide that by 15 mgs per mil. And how many mils do we need of morphine?
5.09.
5.09. I'm going to put 5.1 because that's what we can draw up. Okay.
Okay.
And that is our first part of the CRI. So you guys just did a CRI problem. Super hard, right? It's not. We just get all freaked out by it, right?
Too many numbers.
Yeah. Okay, so now for ketamine, okay? Ketamine, we're gonna set it up very similar. So 0.018 milligrams times our kilograms. So that would be if I just did a bolus of that, but I don't want a bolus. I want this to be over a period of time. So I'm going to multiply in my time, which is a minutes in this one. So 240 minutes. And now we just do our math. So 0.018 times 38.18 times 240. What'd you guys get?
164.9.
Good, 164.9 milligrams. Okay, now we have to factor in our concentration. So our concentration is divide that by 100 mgs per ml. Okay, and what do you get?
1.64.
1.64, okay. Which you're gonna draw up 1.6, or it's getting closer to the
Right.
7, but we'll put 1.6 mLs. Okay. All right, so lidocaine. Okay, so fill that out. 4 mgs times that 38.18 kilograms. And we're back to hours again. So we have 4 hours worth. Okay, so 4 times 38.18. Oops. 38.18 times 4. What do you get?
610.88.
610.88 milligrams. Okay, so what's our concentration? How do we figure out our concentration?
Divide by the
2% is equal
2%.
to 20 mgs per ml.
Okay, so 2% equals, how did you get 20 mgs per mil?
My brain just adds the zero.
I know, right?
Yep,
Two.
our brain adds the zero,
Isn't it, is it
except
2% of 1,000 mLs?
it is 2% of a certain amount. Yes. But how do we figure that out?
2 grams per 100 mils.
Good. 2 grams per 100 mLs. So if you look on a bag or a bottle of lidocaine and you look at the back of it as well, it will tell you that there are 2 grams of lidocaine in 100 mils of aqueous solution, which just means a type of saline or whatever, right? So any percent that you ever get is, X percent is X grams over 100 mLs. Always in 100 mLs. Okay. Does that mean the bottle has 100 mLs in it? No, it just means that when they created that medication, that is the concentration of that solution and they put it into whatever bottle. So if there's 10 mils in that bottle, it's still going to say on the back of it, X grams over 100 mLs. Okay. So just FYI. All right. So when we do this, right, this is where it's why it's important that you guys know this step and not just the add a 0 or multiply it by 10 or whatever. Okay. Is that if on the VTNE they give you which one of these is equal to that 2%, and then they said, oh, 200 mgs per 10 mLs. Okay, that is actually correct compared to what if they said, well, 2 milligrams per ml. That could throw you off, right? So just know that it might not be in the most simple form, but it's still equal to that. Okay. So how we figure this out is 2 grams. So 2 gram is 1,000 milligrams. Okay. So 2 of them is 2,000 milligrams over that 100 mLs, correct? So how we get rid or simplify it is that we have 2 zeros on the bottom. So I can cross those 2 zeros out. But if I cross those 2 zeros out, I got to cross out 2 zeros on the top. Okay. So that leaves me with 20 mgs per ml. Right. So you're absolutely right. You can add that 0 to there or multiply it by 10 as the cheater method and be able to do it quickly. But also just know at least where it comes from, because otherwise I'll come and find you and hunt you down. All right. So now that we figured out our concentration, we are going to divide this by 20 mgs per ml. And how many mils do we need?
30.5.
Good, 30.5 mLs. And look at that. You guys just did 3 CRIs in what, 5 minutes, if that? Pretty
So
awesome.
I get when it's like this, but I don't know why I always have like the hardest time with CRIs.
Yeah, because you're freaking out. You're freaking out over it. Let's do this one. Because this one might freak people out because it's in micrograms, right? You can probably know where I'm going here.
Yes,
So
Fentanyl.
fentanyl, right? So let's say we want our fentanyl to be at 3 micrograms per kilogram per minute. Okay, just making something up. Okay. And then we have a patient that's, let's leave him at that 38.18 kilograms, just for whatever. And then let's say that we want, I'm going to change it up on you. We want to make it so that each microgram equals the rate that they're at. So in this case, we want it to be 3 mLs per hour. Does that make sense? So you might do this in practice where if you turn it down to 1 ml an hour, it makes it that it's 1 microgram per kilogram per hour. Okay. Actually, I'm going to change this to hours. Just make it easier on you guys per hour. Okay. If so, if we change it to 2 micrograms per kg per hour, then it's going to be at 2 mLs per hour. Does that make sense? So you can go up to 5 essentially and do it that way.
Why
So
is that?
it just makes it really easy if you're like trying to manage that patient's pain that maybe they're really painful. You can increase the amount and not have to make a new bag of fluids or whatever. Okay. Or you can decrease the amount too. So maybe like you're cutting them down from those pain medications. So it just makes it really easy to be able to do it.
So is that just like a given, like 3 mics per kg per hour is 3 mils an hour just off the bat?
No, but like in most hospitals that you work in, they're gonna probably try to do something like that. If they don't do it in like a fluid bag situation, like the one that I showed above.
Yeah.
There's like 3 different ways that you can do CRIs. You can have it in a fluid bag.
Yeah.
All together, right? But we're now starting to get away from the all together part because what if you just want to change the morphine of it or you want to change the ketamine? Now
Yeah.
you can't. So now, of course, we put them in 3 different pumps all separate, which is kind of annoying, but it's kind of nice at the same time, especially if you're like a really painful pet. If you have a pet that's just like going to surgery and you're putting them on a CRI and then they're going to be off of it afterwards, that's maybe a different situation. But if you're in an ICU, you're probably going to separate them out. Okay.
Yeah.
So in this case, we can come up with whatever hours that we want to draw up. All right. So, what I'm going to do in this situation is let's just draw up 12 hours worth. Okay. We're just going to make it somewhat easy, 12 hours. All right. So our goal here is that we want this medication to be at 3 mLs per hour. And that's our goal. And I'm going to show you guys how to do it. Super easy. So, if I have it at 3 mLs an hour for 12 hours, how many total mLs will I need of my fluid?
36.
36. Okay, so 36 mLs is my total that I'm going to want to draw up, whether it's saline and fentanyl together, right? That's both. So I'm going to need a syringe that has 36 mLs an hour or to place it in a bag or whatever, but you're going to need that. All right. So now I'm going to fill out all this information. So 3 micrograms times that 38.18 kilograms per hour, and we want 12 hours. Okay. So, also my concentration of fentanyl is 0.5 mgs per mil. Okay. So 3 times 38.18 times 12. What do I get?
1,374.48
Very good.
micrograms.
Micrograms. Very good. Okay, so it's a lot, right? But it's not. So our ultimate goal here is to get into milligrams because that's our concentration. So how are we going to get that micrograms into milligrams?
Divide by 1,000.
Very good.
Yeah.
Divide that by 1,000. Okay, because we want milligrams. All right. So how many milligrams do I have?
1.37.
Good, 1.37 milligrams. All right. And now I need to figure out how many mils I'm going to do. Okay. So now I can use my concentration. So I'm going to divide that by 0.5 milligrams per mil. Okay. So divide that by 0.5 and I get 2.75, right?
Yeah.
Mils. Okay, you can go to 2.8. Let's just go to 2.8 to make it easier. 2.8 mLs that I'm gonna need. All right, so I'm gonna need 2.8 mLs total of my fentanyl. All right. So remember, we have to get it to run this at 3 milliliters per hour. Okay. But our total is going to be 36 mLs. All right. So we're going to take 36 mLs and we need to find out how much saline we're going to draw up. Okay. So if we only have 2.8 mLs of that fentanyl, we got to take that out of the equation, right? 2.8 of our total. So how much saline am I going to need?
33.2.
33.2. So 33.2 mLs of saline. And then that 2.8 mLs of fen. Okay. Now you can run that at 3 mLs an hour, and that equals your 3 micrograms per kilogram per hour. Then your doctor's like, oh, he's really painful. Let's turn it up. Okay, what do you want to turn it up to? Let's turn it up to 4 micrograms per hour. And then you're like, okay, cool. I'll turn up my fluid pump to 4 mLs per hour. Make sense? Yeah. So it is kind of nice to do it that way. If you have a patient who maybe it was hit by a car and they're, going through all different types of pain, or you're turning them down. So I really like this method once you guys get some practice with it, to be able to manage your pets that way in practice, because you can change it, or maybe it's a back dog or whatever, so that's kind of nice. And you can do this you don't have to just do it for fentanyl. You could do it for other drugs too. It's just, you have to find out how long you want to run this over, whether it's 12 hours, whether it's 24 hours, draw up that amount. So how much that total is, and then subtract your drugs from that. And now you can change it up as you go. So make your lives a little easier. We do that too a lot with like lidocaine. If you have a patient that's having VPCs, we'll change that rate to be like, oh, let's run it at, 10 mLs an hour. Make it simple on yourself versus having to do some wonky, rate or whatever. And then, so you're just diluting it. Okay. So that's our one method. The other method you can do is not put any saline in it and just run your straight on fluids. And that's really easy to do if you have enough to be able to do it. So like in this case, in fentanyl, we wouldn't be able to do it because it's 2.8 mLs for 12 hours that we need. So if we divide that by 12, you're giving 0.23 mLs an hour. So that's kind of hard to do, like even on a syringe pump, right? That's kind of hard to do for that pet to actually get the medication. So that's why we dilute it out. Okay. But say you figured it out where, maybe an animal's getting, let's say lidocaine. They are getting 2.5 mLs of total lidocaine in an hour. You could technically go ahead and do just straight up lidocaine like that if you'd like. That's fine. All right. So any questions on those?
So how do you get, oh, never mind, sorry. This one always gets me.
No, you're good. So just remember with any of our CRIs. Oh. Sorry, my dog has to bark. Any of our CRIs, we're gonna add in that time. Okay. So you have to have the time amount, whether they give that time amount to you in some form or another. Like up here, they didn't really give you time, but they told you how much you had left and that you had to figure out that time. Or if they say, we want to draw up enough for 12 hours, then you can do it that way too. So you just have to factor in the time. All right, we'll practice more of those.
Thank you.
Yeah. All right, so let's see. Let me get to our ECG one. Because I know that was one of them. I think it was this one. Maybe. Hopefully. Oh, it's not. It's not that one. It is this one. Ah. Or so okay. Let me grab one of these so then we can do it. All right. Actually, grab this one. All right. How many of you guys learned how to do ECGs in school? Anyone?
Not
I
me.
feel like yes,
No?
but not
Yes.
really.
Yes and no, right? Okay. All right. So I'll kind of explain a few things. So when we're doing ECGs, we have multiple speeds that our ECG is essentially. Okay, so we need to know the type of speed that our ECG is being produced at. So many times we'll see it at 25 millimeters per second, or you'll see it at 50 millimeters per second, and you can always change them on the machine too. All right, but important to know is that in this box right here, okay, there are 5 little boxes that go across. All right. One of those little boxes, so one little box, one small box equals 1 millimeter. Okay. So if we have 5 small ones in a big box, okay, that means that there's 5 millimeters per big box. So 1 big box equals 5 millimeters. All right. So when we're counting seconds, we need to know these because this is how we're going to get our time. All right. So how many big boxes are in the 25 millimeters per second?
5.
5. Good. So 5 big boxes. Okay, because 5 times 5 is 25, right? Now, how many big boxes are in the 50 millimeters per second?
10.
10, good. So 10 big boxes. Okay. So this is how we're going to do time for our patient. Okay. We're going to figure out how many seconds worth of this ECG we actually have. All right. So if this was 25 millimeters per second, it'll say, okay. We are going to count these boxes across to see how many seconds we have. So I have 1, 2, 3, 4, 5. So this is 1 second worth right there. Okay. I'm going to keep going. 1, 2, 3, 4, 5. There's another second. 1, 2, 3, 4, 5. So 3. 1, 2, 3, 4, 5. 4. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4. And 5 would be right here. I think I cut it off a little early. So 6 seconds. Okay. So if I have 6 seconds worth of my ECG, okay, we need beats per minute, right? So beats per minute is our goal. Okay, so we only have 6 seconds worth, but we're gonna need 60 seconds, right? So it's over need over have. Okay. So we need 60 seconds, but we only have 6 seconds. Okay. So we have to come up with a multiplication figure here that we can multiply to get that 60 seconds worth of a heart rate. Okay, so you guys do the exact same thing when you're counting your heart rate, when you're listening to your pet. How long are you listening for?
15.
15 seconds?
15 seconds.
Okay.
Mhm.
So, but we need 60, right? So 60 over, you guys are doing 15 seconds. So what is your multiplication factor that you come up with that 15 seconds to get 60?
4.
4. Good. So we're doing the exact same thing. It's just on paper. Okay. Some of you might listen for 30 seconds and then you multiply by 2, or you listen for 10 seconds and multiply by 6, right? So it's the exact same thing. It's just on paper. Okay. So here we have 60 seconds, or we need 60 seconds, sorry, and we have 6. So our multiplication factor is 10. All right. So what we do from here is we count our R waves, and then we're going to put our multiplication factor in, and that's going to give us our beats per minute. Okay. So the R waves that count, they have to be full, complete.
I'm gonna forward it to the 2 guys that I work with that are taking their VTNE, because this one's all about the math.
So we are going to count all those R waves. And then the only ones that count are the full and complete ones. So let's count this first one just so that we are accurate with ourselves, but we're not going to count this last one because it's not a total full complex. Okay. So we have 1 R wave, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 R waves, and our multiplication factor, remember, is 10. So 13 times 10 is what?
130.
130 beats per minute. That's it. Easy, hard. Okay, so we break, it's a little easier, right? So we break it down just like as if we were to listen to that pet, but we're not listening to the pet, we're looking at the pet's heart rate. Okay, so when this is good to do, because everyone's like, well, we have ECG machines. Yeah, we know. However, sometimes our ECG machines double count things, right? And so it's good to double check that if they are double counting, because sometimes these T waves get really high and it might double count and call that an R wave when it's not. So just printing that out and looking at it and going, oh, it's actually double counting is really helpful. Okay. Or if you work in cardiology and do it all the time, then you can do that too. So, all right, here, let's do another one. Let's do the nice infamous. All right, let me get back here. So here, let's also do the 25 millimeters per second. Okay. So we'll count our boxes, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and these are extra boxes, so we're not going to count anything after that. Okay. So our next step, right, is our need over half because we need 60 seconds. So 60 seconds. See, and we haven't even looked at the ECG yet. 60 seconds. And how many seconds do we have? We have 4. So our multiplication factor is going to be 15. So let's count our R waves. Okay. Now remember, we have these two right here that look really wonky, right? They're still beats, so let's count them in there. They're just not beating very well for us. What are these? Does anyone know? Those beats? Anybody know?
VPC.
VPC, very good. Okay. So that's a VPC because we don't see a clear P wave in there. And anything what's we call wide and bizarre is going to be a VPC. So that's your like classic looking VPC. Okay. So we're going to count our R waves. 1, 2, 3, 4, I guess I'd say 5, 6, 7, 8. All right. So we have 8 R waves times that 15, because that's our multiplication factor from up here. What do we get for our heart rate?
120.
120 beats per minute. Okay. So
We don't count. Oh,
yeah,
sorry.
go ahead.
We don't count the initial, or because it's not like a
This
full
right here.
beat.
Correct.
Yeah.
Yep. Yeah, that's not a full beat. That's going to be just this part of that VPC. So we're not going to count that.
Okay.
Yeah.
Where?
Go ahead.
Hold on. 1, 2, 3, 6, 7. Where are you getting? Are you counting the bottom one?
Yep. These guys right here. Yeah.
Yeah.
Yep. So I have 1, 2, 3, 4, 5, 6,
Oh,
7,
okay,
8.
that's where I was off.
Yep. No, you're good. So, let's go back to this guy right here. What would you say is the rhythm on this patient? Do we have a P wave for every QRS?
On the red one, is that the one
Yep.
you're looking at?
Yeah, the
Oh,
red guy. Yeah.
Yes.
yeah,
Yes,
pretty
there's
much.
a P wave there, right? That's good. Is there a QRS for every P wave?
Yeah.
Yes.
Yes. Okay. So that means that we don't have any like VPCs or anything other wonky thing going on, right? So that means that we have a sinus. It's sinus at least, right? Because there's nothing wrong there. But is it sinus rhythm? Is it sinus tachycardia? Is it sinus bradycardia?
Sinus rhythm.
Sinus rhythm, very good, because our heart rate is 130, so we're good. It's not horrible, right? Whether it's a dog or a cat. I mean, cat, it might be a little bit lower than what we're used to in a hospital, but if they were resting at home and it was 130, then that's pretty good. So yeah, we're sinus rhythm. Okay. So down here, we already said what it was, right? We have premature ventricular complexes or ventricular premature complexes, however you want to call it. Okay. So that would be our rhythm that we put in there. We have VPCs going on. So depending on and if it's conversion or whatever, they may want to do something about that. They may want to give something. But sometimes we'll have occasional VPCs even on a normal pet, and that's okay. But it can't be more than occasional, right? All right. So when we're also talking about rhythm too, just know, because people get really like, oh my gosh, there's so many different rhythms we can have, right? So we talked about our actual ECG. So here's our P, Q, R, S, and T, right? So your P wave is, everyone knows it as that it is a atrial
Yeah.
depolarization. Yeah.
Mhm.
So if
Mhm.
there is if there's a lack of P's, well, I should say this. If there's something wrong with the P wave, then it's an atrial issue. Okay. QRS. Okay. The QRS, remember, is ventricular depolarization and atrial repolarization is in there. So the atrium is repolarizing to do the next beat, right? But it's the ventricular is depolarizing at the end, or ventricles are depolarizing. Okay. So if there's something wrong with the QRS, it's a ventricular issue. Ventricular. Okay. If we see something wrong at the T waves, we're looking
What
at
did
our
you
electrolytes. Yes.
go ahead?
So atrial.
What is yes.
Okay. This is ventricular depolarization. And atrial repolarization. T wave is ventricular repolarization. Okay. So if we see something wrong with the T waves, we're going to be looking at our electrolytes, right? If there's something wrong with the QRS, that means that, hey, we have a ventricular issue. If there's something wrong with the P wave, then there's something wrong with the atrial. So that cuts your stuff in half of if there's something wrong that I can look at these specific items, right? So if my P waves are looking like this, and then I have my QRS, and then it's going like this again, QRST, da, da, da. So it looks like that. We know that there's something wrong with the P waves, right? My QRSs look like crud, but. Okay, so what could this potentially be? Rather than thinking of the whole laundry list of things.
Atrial flutter.
Okay, so we have atrial flutter. What are some other atrial issues? Atrial fibrillation. Okay. And that's the two big ones, right? So we've already cut our stuff in half just by knowing that there's something wrong with the P wave. Okay. So the answer to this, what is it, right? Is atrial flutter. Remember, sawtooth, people think of flutter like fluttering butterflies, right? But in ECG land, it's like sawtooth, very blech. Okay. When we think of fibrillation, if you guys think of ventricular fibrillation, right? This is what it looks like. Okay, or it might be fine. It might be like that. Okay, it's right before a systole. So if this is what fibrillation looks like in the ventricle, you're going to see that if it's atrial fibrillation, you're going to see that fibrillation in the atrium. So you're going to see it be like this, and then you'll see the QRS. Okay. And then, so QRS, and then you'll see this again, and the QRS, and this again, and the QRS. So it's too hard to tell really where the T wave is, where the P wave is, because it's just fibrillating. It's just the atrium is going like quivering, okay? Rather than actually taking that beat that it should, okay? Does that make sense?
Yeah.
Okay.
Is it flutter first and then fibrillation? Is that what,
They're
or
just
not
two
really?
different. Yeah, they're two different separate
Okay.
things. Now, when we talk about ventricular issues, so you'll see first, you'll see VTAC. So you'll see all those VPCs coming in.
Mhm.
So they're like VPC, they'll look like this.
Yeah.
Okay. That's first. And then from there, you're gonna see ventricular fib, and then you'll see a systole.
Yeah. Okay.
Okay. So if you ever see ventricular tachycardia, we have to do something immediately because we want to prevent this. And then,
That,
of
yeah.
course, for fibrillation, we want to prevent that.
Yeah.
Okay.
Sense.
All right. So any questions on that? That's like the very basic things. Of course you're gonna have like heart block, first degree, second degree, third degree, like that comes with time to be able to notice those things, but actually understanding this very, very basic stuff is really important to get you started. Okay.
So like,
Yeah.
oh, sorry. Like the block cat, the
Oh yeah.
raised T waves, right? Is that
Mm-hmm.
the whole?
To the
Okay.
tented T waves, yeah. So that is such a good point. So we say the T waves are electrolytes, right? And so if you see that tented
Mhm.
T wave, you're going, "Ooh, I need to check my electrolytes," because as you guys know, in block cats, our potassium level gets really, really high. And so
Mhm.
when that happens, then you're gonna see those T waves get high. It's basically telling you, hey, we need to correct this because our patient's in danger. It can cause some other arrhythmias going on too. It'll
Mhm.
get worse and worse. So that's why we actually need to unblock that cat right away, is because we need to protect that heart.
I see.
Okay.
So not only is it obstructive, it's
Yes.
okay.
It's a cardiovascular. Yes, it's super, super painful, uncomfortable for that cat and all of that, right? But at the end
Mhm.
of the day, the biggest thing that we have to prevent is that heart from stopping. So
Mhm.
and then in order to do that, we can give certain medications, and then I can unblock that cat and get that potassium to be excreted out. So
Mhm.
in the meantime, we do stuff. So maybe you're not able to unblock the cat, right away when they walk in the door, which is normally what happens. We can't do that right away. We got to set things up. But there
Yeah.
are things we can do, like we can give some insulin and dextrose and some calcium.
Insulin and
Glucose.
dextrose because of like just so the body excretes it. Is that like the whole
Yes, in some
thought?
sense. So the insulin actually is the one that pulls out that potassium.
Okay.
And then we have to give the dextrose because obviously these cats are not diabetic, so we have to like make sure that they don't lose too
Become.
much, right?
Okay.
And then you can do like calcium gluconate too, was also a
Yeah.
help to pull out that potassium out of the cells. And then you can also do like a big cystocentesis on them if their bladder's not horribly too expanded. If you're
Oh,
still trying to buy some
set everything
time.
up.
So
Yeah.
whether you try to take off like 60 mLs of urine or something, right? Like try to take out
Yeah.
off as much as you possibly can.
Yeah.
And then unblock them. Because some might come in and they're really, really doing bad.
Bradycardic and
Yeah,
bad.
they're
Yeah.
really doing bad. So we can do those types of things until you can get everything set up and also you know, put them under sedation and stuff too. So
With their bladder being like so, I guess, large, right?
yeah,
Doing a cysto, does that um
like risk of rupture or something.
yeah, like
I
that's
mean,
like
there's always a risk of like even just a little bit becoming a uroabdomen too. But at that
yeah.
point too, it's like kind of weighing out your risks.
I see.
It's not gonna like pop the bladder if we think of
Yeah.
it, but there could always be from that little hole that was there that, you know, urine
It'll
does
leak.
come out
Yeah.
a little bit. One thing that they do notice too is because of the extreme amount that you are taking out right away, and from cystocentesis, because they're not doing so well, they sometimes do vomit after you do a cystocentesis.
Oh, interesting.
So it doesn't happen all the time or whatever, but if you do see like a blocked cat vomit after you've done that traumatic cysto or whatever, I guess you wouldn't say it,
Yeah.
whatever. That can be from that.
Oh, wow. I
My
had no.
personal cat was blocked, and that happened when we got a cysto on him.
Yeah,
Oh,
see, it's
no.
crazy, right? So just kind of keeping that in mind. I mean, they could also be vomiting and stuff too, even prior to that. Like if they're at home and they're like severely blocked or whatever, like it can
Mhm.
definitely screw with, you know, them wanting to vomit. So,
Yeah.
but yeah, just keeping that in mind. So, okay. So I want to go over one thing really quick with you guys on, because I know some schools don't do this either. And this is for anesthesia math per se. So if I have a tank of oxygen, all right, we have to know like how much oxygen we have left in our tank so that we know when to change it, right? So we have two types of oxygen tanks that we typically use in practice. So we have a really big one, and then we have a little one, okay? Don't mind my drawings. So our big one is called an H tank, so H for huge. And then our other one is called the E tank for emergency. Okay, meaning you can carry this around a little bit better than obviously an H tank. If anyone can carry around an H tank, you can, you're very strong. So, in both of these tanks, we have 2,200 PSI in that tank. Okay, so that means how much pressure of oxygen is in that tank. All right. So it's the same amount of pressure. Now, how many liters of oxygen are in the tank is a little bit different. So in the H tank, we have 6,600 liters. And in the E tank, we have 660 liters. Okay, so a little bit different. When we divide that 6,600 divided by the 2,200, all right, we're gonna get what? $6,600 divided by 2,200.
3,300.
Mm,
33.
3. So
3. Sorry.
66, yeah, 3. So 6,600 divided by the 2,200, we get 3. Okay, so this is a constant in order to do our problem. So that's why I'm telling you this. Now, this 660 divided by 2,200 is 0.3. So that's a constant that we'll use. So when you do these problems, it's nice to know, yes, how much is in the tank when you first start, or the PSI or whatever. But if you remember those constants, just like how you guys remember how to do the cheat method for your percentage too, right? If you can remember what these constants are, you're in good shape to do this problem. All right. So it says we're going to start our date and open that E tank. So turning it on, and we note that on the manometer here, we're at 1400 PSI. So, or somewhere around there. Remember that our total that we can have is 2200 PSI in either tank. Okay. So, but we're at 1400. And we want to maintain our patient at 2 liters. This should be per minute of oxygen. So how many minutes are we going to have left? All right. So if we have 1400 PSI, we take 1400 PSI and we are going to multiply that by the constant. So it's an E tank. So our constant is 0.3. Okay. So when we take that 1400 times 0.3, we get 420 liters. Okay, so that's how many liters are left in our tank. All right, now we need to know how many minutes are going to be left for this, for our patients. Okay, so we're going to be running our patient at 2 liters per minute. So we are going to divide this by 2 liters per minute, and this is going to give us how many minutes we have left. All right. So divide by 2, we end up getting 210 minutes. Okay. Did you guys learn this in school?
Nope.
Nope.
Oh Lord. Okay.
They talked about it, but I don't know. I don't really remember.
So again, why this is important is what if you're going to be starting a really long surgery or you're starting a dental, and we all know that dentals take a little bit longer in time, right? So if we have 210 minutes, you can then say, okay, well, how many hours do I have left, right? So then divide that by 60 to get your hours, and we have 3.5 hours. So can we get through this next procedure without changing our oxygen, right? So or how many procedures are we going to be able to do in this amount of time? If I have 3.5 hours left, am I going to be able to get through 4 surgeries? Maybe not, you know, so when should I change that oxygen after what surgery? Okay. So just keep that in mind. It's super, super easy to do. If you especially keep in mind what these constants are, it makes it a lot easier. Okay. Any questions on that one?
What paper did you get that from?
What do you mean?
Which
Um,
sheet?
What document?
Oh, sorry. I'm like, what paper? It came from my brain. No, I'm just kidding. It was on Math Week 4, the 4th part one. It's number 9. All right. Somebody mentioned RER as well, so I'll just go over that one really quick. So let's see, what do we want to do? How about a 32-pound dog? That we need to figure out their RER. Okay. And then we'll talk about MER after that. Okay. So how do we figure out RER? What's our formula?
30 times kigs plus 70.
Okay. So 30 times kigs plus 70. Is that what everybody uses?
What number is this going to be? Is that on a sheet? Is this going to be on a sheet?
It might be. I know that I talked about RER somewhere within our math, but
I do too.
I'm just making this one up right now. So
Okay.
So what other formula is there? Oops. Anyone know? Anyone have a? I'll give a hint. 70 times kilograms to what? 0.75. Anyone ever see that?
Yeah.
Yeah. That's the one we all like go, oh, we don't want to do that, right?
Yeah, that one confuses me.
Okay, so ideally, in the most ideal situation, we use this formula for patients that are like 2 kilograms and under. All right, and then everyone else, we're supposed to use this guy. Okay, so let me show you really quick the easiest way you can do this one right here, and not be as confused. All right, so we have 70 times, okay, kilograms times kilograms times kilograms. All right, and then we square root it twice. So if you're trying to figure out that answer, we just take kilograms times kilograms times kilograms, and then press the square root button twice on it. And then after that, you're going to multiply by 70. Okay. This part makes up for this guy right here.
So, like let's just say we're 10 kilograms.
Mm-hmm.
So it'd be 10 times 10 times 10, square root times 70.
Correct.
Does my question for the VTNE, does
Mm-hmm.
the basic calculator that they provide, does it
Does it have the square root buttons? I
have like a
don't
square root? Does it have
believe.
percentages? I mean,
Yeah, so I don't believe that it will have the square root buttons, and that's why we have to use this. But I do like to tell you about this in case we are in practice and they want to utilize this. Not only for RER, but they also have this for as like a fluid rate calculation too. Like fluid rate for dogs is technically 132 times kilograms to 0.75, and cats is 80 times kilograms to 0.75. You may work with a doctor that wants to use these calculations. So knowing how to do that is really good. So again, you take that kilograms times kilograms times kilograms, square root times 132 or times 80. Okay. So yeah. Now let's try to do both of these, just so you know. All right, so we have 30 times, what's our kilograms? 32 pounds.
14.5.
14.5. Okay. 14.5 kilograms. Okay. And then plus 70. All right. So 14.5 times 30 is 435 plus 70. 435 plus 70 is 505 kilocalories. Okay. Now, if we do this other one, so we have 70 times 14.5 kilograms times 14.5 kilograms times 14.5 kilograms. And then we're going to square root. Okay. So 14.5 times 14.5 times 14.5. And then we are going to square root. And when we square root that twice, don't press enter. Okay. We get 7.43. And then we're going to multiply that by 70. And we get 520 kilocalories. Okay. So this is why we're a little bit off, right? with using this one at
Mhm.
the top. It's a little bit lower than this guy. This is more around what that pet should get because we are doing a calculation based on body surface area in this, okay? But again, for the VTNE, I believe that you can only do this guy because of that basic calculator. Maybe someday they'll change it, I don't know. So since we have that 505, okay, what if we said this pet was pregnant? What should we be multiplying this 505 by kilocals by? Is it 2? Is it 3? Is it 4?
I'm gonna guess and say
One.
2.
2. Okay. Any other guesses?
3.
3. Okay. 4. 2, 3, 4. Any other guesses? Um, all right. So if you guys ever look up the maintenance energy requirements for animals, I think I put it also in your study stuff too. So they're all different ones. Okay. So if we have, um, like a neutered pet versus an active dog versus an inactive dog or weight loss or working dog, we are going to do those types of things, or we are going to multiply it by those types of things. So in this case for a pregnant animal, it also depends on, again, how active that dog is. So we're going to do somewhere between 3 to 4, multiply by 3 to 4. Okay. So say they're at the end of their pregnancy and they're a bigger animal, probably has multiple pets or puppies, I should say, in there or whatever. And it is a bigger dog, actually, 32 pounds. And maybe this is a border collie. They're already an active animal. We're going to multiply that by 4. Okay. So some of the things that just for you guys to know. So like a neutered adult dog, that's still kind of like normal activity is you would multiply by 1.6. An inactive adult dog, which we have a lot of inactive adult dogs, we're going to multiply by 1.2 to 1.4. An intact dog, adult dog, is multiplied by 1.8. Weight loss is 1.0. Okay. And working dog, again, depends on how much they're working, right? So if they're like a sports agility type of thing, it could be 2.0. It could be all the way up to multiplying by 8 if they're maybe on a farm and working constantly, or maybe they're Iditarod dogs, right? So they're running like 1 billion miles a day. Okay. So that's how we have to multiply it by. So it's all really dependent on the dog and their dog activity and their metabolism. All right. So if you have a really lazy bulldog that lays on the couch all day, you can't just give them the same calorie intake as a border collie who's running all over the place. All right. So that's where it's not great to use the back of the bag that just tells you by weight what to feed your dog, because every dog is going to be different. Okay, so that's where we have to do our calculations and help people through that. All right, they're looking at the back of the bag as like average dogs, and we don't have that many average dogs. We have all different types of dogs, and same thing with cats. So this is where we run into animals being overweight or underweight. So 505 times 4. Okay, 505 times 4 is 2020 calories, kilocalories. All right. And our average puppy food, because we want to feed puppy food for our moms, our pregnant moms, is about 375 kilocalories per cup. So divide that by 375 kilocalories per cup. All right. And how many cups then are we going to feed our dog here? 5.38 cups per day. All right. So it's a pretty decent amount of food. All right. Any questions on that? DER is the same thing as MER, maintenance and daily. That's just the difference. So they're interchangeable. I don't know anything about the calculator that's used in other tests or other prep things. So, what do you multiply if the dog's overweight? So if we want to have weight loss, it's technically on like our charts. It says for weight loss, somewhere between 0.8 to 1.0. So, but I always look at it as, what if that pet parent was feeding 1.8 times 1.8? Maybe they're just a little bit chunky. We don't necessarily have to go all the way to 1.0, right? Maybe we can say, well, they're a little bit chunky. That's kind of a lot for maybe your dog who is, kind of lazy, or they have less activity now. So maybe we start at 1.4. So multiply by 1.4. If they still aren't losing as much weight as we want, we can always move it down. Maybe we'll move it down to 1.2 and just slowly move them down. Sometimes if they're at a little bit higher here, and then we just jump all the way to 1.0, they feel like they're being starved, and we don't want to do that either. So just keep that in mind when you're in practice. Obviously, like if you're doing something on tests and they say weight loss, you're going to pick 1.0 or whatever, that's fine. But in practice, drastic changes are kind of hard. So, all right. Any other questions? Great. Let's see. Oxygen. Okay, I know this goes back to oxygen. How do we figure out the bag size? Yes, bag size. Very good. So, oops. If we're gonna do bag size, let's move that down. All right. So say we have, let's do this 32-pound dog again. 32-pound dog. So our 32-pound dog is, we need to figure out the bag size for. So our 32-pound dog is how many kigs again? 14.5 kilograms. Okay. So in order to figure out bag size, we have to know what tidal volume is. What is tidal volume? What's the formula for that?
10 to 20 mils per kg.
Good. 10 to 20 mils per kg. Okay. So this means that we're going to have two separate answers for this problem. Okay. So we're going to take that 14.5 kilograms. All right, and we are gonna multiply it by 10 mils and 20 mils. Okay. So we are gonna say that the first part, so 14.5 times 10 is 145 mLs, right? And then 20 is 290 mLs, right? So in order to get bag size, we then, so that's the tidal volume. That means how much that patient is actually taking in a breath per se, or should at least be taking in a breath, for one breath. All right. So now to do bag size, we have to take that answer and multiply it by 6. All right. Now, the sucky part about this is that certain books that you read are going to say something different than 6. Okay. Some may say 5, some may say 3. It all has varied throughout the years. But I think of it as there's 6 lung lobes. So that's how I remember 6. I have this confirmed at least by a few VTSs in anesthesia and analgesia that it's 6. That's what they use. So I figured if they're using 6, then I'll keep going with the 6. So we're going to take 145 times 6, and we get 870 mLs. All right. And if we take that 290 times 6, what do we get? 1,740 mLs. All right. So now we have to change it into liters because we need a liter bag. Like every bag is in liters, not milliliters. So let's divide that by 1,000, divide by 1,000 to get liters. So we have 0.87 liters, and this is 1.74 liters. So this means what type of liter bag should we use? Okay, we all know that we don't have a 0.87 liter bag or a 1.74 liter bag, but what within this range can we use for this pet? So if I were to say, oh, pick a 2-liter bag, do you need a 2-liter bag?
1 to 2 liter.
Okay.
You can use the
So
one.
we can use a 1-liter bag, or should use a 1-liter bag. What else could we use? 1.5 liters if you have a 0.5. What about 2 liters? It's over, right? It's over the total amount. So we might have too much dead space for that pet. So try not to use that. Try not to, use something within this range first. Okay, so that's why it's nice to have the 10 to 20 because you can see the full range of what you need and then choose wisely from that, whether it's a 1-liter bag and then grab the 1.5, those types of things. But you shouldn't necessarily need that 2-liter bag. All right.
Can you go over oxygen as well? Like
The oxygen flow?
Yeah.
Yeah.
It always messes me up.
Yeah, so we have our rebreather. So the rebreather is meaning that they are going to rebreathe recycled gases. So their formula is 20 to 40 mils per kg per minute. And then non-rebreather is 200 to 400 mils per kg per minute. All right. So if we have anything greater than 7 kilograms, it gets the rebreather, and anything less than 7 kilograms gets a non-rebreather. So reason being is that the non-rebreather changes all those gases after each breath. So they get brand new fresh gases after each breath. So it makes it easier for us to change level of anesthesia and stuff for those small pets versus the non-rebreather, or I'm sorry, the rebreather, where we can use it for some of our bigger pets. Because if we put them on the non-rebreather, the big pets, we're going to be wasting a lot of gases. So we don't necessarily need to do that. So in the cases of people that are like, well, they're 8 kilograms, but maybe they're a little chunky, maybe they still want to put them on the non-rebreather. That's kind of like the exception to the rule, or they could even be 10 kilograms, but they're chunky 10 kilograms, right? They're an exception to the rule because we can still use a non-rebreather. There's nothing wrong with it. It's just that we might waste a little bit more of the gases than we really want to. Okay.
Would it be easier to change their
Yep, to change their anesthetic rate and all
that?
of that.
Yeah.
Yeah. So, so obviously for VTNE purposes, they're going to give you something very simple to be able to do. They're not going to throw like, well, they're fat, so, you know, put them on something different. No, they're not going to do that. So let's say that our patient is 14 kilograms. Okay. So first, which one are we going to use? Rebreather, non-rebreather, which one?
Rebreather.
Rebreather, very good. So we're gonna take our 14 kilograms, okay? And for our rebreather, it's 20 to 40 mLs. So same type of thing. We're gonna have a range that we're working with, okay? So 14 times 20 is 280 mLs per minute. All right, and then 14 times 40 is 560 mils per minute. All right. Now remember that our oxygen is in liters per minute, so we're gonna have to switch that. So divide that by 1,000, divide by 1,000. So we get 0.28 liters per minute and 0.56 liters per minute. Now, in order to have our anesthetic machine working appropriately, in order to get the vaporizer to actually create a vapor, we have to run our pets at least 0.5 liters per minute. So even if you calculate it out and this part is less than 0.5, we still have to increase it to 0.5. That it's a minimum maintenance of 0.5, okay? So in the case of this pet, we would run this pet at 0.5 liters per minute. Right? Makes sense?
That does make sense. Yeah, thank
Okay.
you.
Yeah, so sure, you could maybe go up to 0.6 liters per minute because we're really, really close to that 0.6 if they really needed that oxygen. But as long as they're running at 0.5 liters per minute and they're oxygenating okay, there's no need to like bump that up. So how many of you guys, we have a 14 kilogram pet. So that is a 30-ish pound pet. How many of you guys run that pet on a rebreather at 0.5 liters per minute as maintenance? Or what do you run them at?
We normally do one.
One, okay. Usually one, all right. So some people, I've seen them go all the way up to 2 for some of those. Yeah. So this could be why your pets are getting really cold during procedures faster, is if we increase that oxygen to something super, super high, then we're making our pets colder faster because oxygen is really cold. Also, we're wasting gas, wasting a ton of gas. If they only need 0.5 and we're going to a 1, 1.5, or 2, you're just going to waste all that extra gas. So again, this is why these calculations are important to do. Okay. Because remember, the stuff is recycled. So it's like they're keeping some of this extra stuff in reserve in that reservoir bag. Right. Alrighty. So I know some of you guys have some graduation parties to go to and stuff today, so I'm not going to keep you guys forever. But yeah, keep working on that math aspects of things. Practice that stuff. That's why there's all those sheets for you guys to practice. This next week, let me check my syllabus so I'm not off here. I believe we are on, oh goodness. So we are on emergency and critical care.
Hey.
Yay, our favorites. So yeah, work on emergency critical care. I'm gonna organize it a little bit for you guys too. So you might just see me moving stuff around just so that you guys can see it a little bit better. But work on emergency critical care. If you do have time and need to go back to the medical math part, you're absolutely able to. That's totally fine. Because I know that the math one was pretty long for you guys. So it's okay if you didn't finish it, you can go ahead and work on that too. So, all right. But I hope you guys have a great rest of your weekend. And yeah, reach out if you guys have any questions.
Yes, I have one question.
Yeah.
So like I know what is this, 12 weeks?
Yeah.
I think I want to do the
8 weeks?
It's
The program that we're doing?
We have a total of 12 weeks that we run through. So there will be certain weeks, if some of you guys are working on like communication and the QPR training, that one's an easy week. There's really not that much that's in there because a lot of the communication stuff we talk about throughout the other weeks too. So that way, since that week is so easy, you may want to work on, some other part, like maybe going back to math, you can kind of gauge, or if you're like, oh, pharmacology looks like it's going to be a long week, which it kind of is, you can start working on pharmacology a little bit early.
So this will take us April, May, June, July. So it'll take us through the end of July.
You are correct. Yep.
Okay. I have already signed up to take my test.
Oh, got it. Okay.
And so
Oop, I lost you.
I'm doing you and I'm doing vet tech prep.
Got it.
My vet tech prep though runs out, or my vet tech prep runs out before I take my test.
Got it.
And I wish I'd have timed that better. So I was just trying to make sure that I had access to all of our stuff.
Yeah, no, absolutely. And depending on when your test is, like say it's only a couple weeks off or whatever, just let me know and I just extend it out until your test day. So
thank you.
Yeah, of course. Obviously, if it's like months and months, then yeah, we have an extension that you can do that's a little bit cheaper, but
it's not. I've signed up to take mine.
Like
okay, I signed up
August
like
something.
mid-July. So
Oh, okay, perfect. Yeah, so the last weeks that we have, so even if it's mid-July, the last week is large animal and exotic, and it's just kind of review. And so I have some other videos too that you could watch our videos from the large animal stuff or whatever. So it kind of works out for some people if they take it like a week early or whatever. So
okay.
Yeah, there's
Thank
plenty of
you.
resources for you. Perfect.
You'll give us the heads up when you change everything.
I will. Yes.
Thank you.
Yeah. You work next Sunday. How unfortunate. I'm sorry. Yeah. So, it will be recorded. Today's is recorded as well, so I'll post that for you guys when it downloads and everything. It takes a little bit of time, so be patient. All right. You guys have a good rest of your day. Yeah, of course, no problem. You guys take care.
Thank you.
Yeah. Bye.
Bye.